Before the sun clears the horizon, while your neighborhood is still wrapped in blue-gray silence, a northern cardinal is already singing. You can hear him from your window, that clean, looping whistle, and you probably think you know exactly what it means. A male calling for a mate, staking out his territory. Straightforward biology. Except a 2019 study out of Duke University's Botanic Garden just dismantled that entire picture. What your cardinal is actually doing at 5 a.m. is something far more precise, more computational, and more desperate than any courtship call. And that's just the beginning, because researchers also discovered something inside the female cardinal that no one predicted. Every birder on the planet has heard the cardinal's dawn song described as a territorial broadcast. The male perches high, sings loud, warns rivals away. Clean story. Except it only holds up until you actually measure what the bird is doing. When Dr. Robert Laughlin at Queen Mary University of London cross-referenced cardinal song timing against predator density, competitor proximity, and ambient light levels, the data produced a result nobody expected. The song's start time each morning is not random, and it's not triggered by sunrise. It is calculated. The cardinal begins singing at a specific, repeatable moment relative to the exact light threshold his eye can resolve. Roughly 0.05 lux, a level so dim it is technically still night. What he is doing at that moment is not courtship. It's reconnaissance. He is acoustically mapping his territory in the window of time when visual predators, hawks, cats, are functionally blind. But his song can still travel up to 800 meters in the cold, dense, pre-dawn air. He is surveying his real estate while invisible. That's not a love song. That's a military operation. Here's where the biology becomes almost architectural. A cardinal doesn't have a larynx. It has a syrinx, a structure sitting deep at the fork of the trachea. And unlike any instrument humans have ever built, it has two independent sound sources that can operate simultaneously. Ornithologist Dr. Franz Galler at the University of Utah spent years threading tiny air pressure sensors into anesthetized songbirds to understand exactly how this works. What he found was that each bronchial half of the syrinx has its own labial membrane, its own muscle group, and its own pitch control. The cardinal can sing a two-note harmony alone. More than that, when he transitions between syllables in his looping whistle, he switches dominance from one side of his syrinx to the other, mid-note, so seamlessly that to the human ear, it sounds like one continuous sound. The muscular precision required for that switch involves 9 separate muscle groups, firing in under 10 milliseconds. To put that in human terms, the fastest voluntary movement a trained pianist can execute takes roughly 50 milliseconds. Your cardinal is executing coordinated breath switching 5 times faster before sunrise, without warming up. For most of the 20th century, female songbird vocalization was classified as either absent or biologically irrelevant. That assumption collapsed in 2016 when Dr. Lauren Benedict at the University of Northern Colorado published a systematic review in Nature Communications covering 141 songbird species and found that 71% of female songbirds produce complex song. Female northern cardinals had been doing it the whole time. The reason nobody noticed is elegant and unsettling. The female cardinal sings from inside the nest during incubation. She's not projecting her song outward. She is directing it downward, through her brood patch, the bare, hypervascularized skin on her abdomen, into the eggs. The acoustic vibrations appear to prime the developing embryos. A 2022 study by Dr. Mylene Mariette at Deakin University showed that prenatal acoustic stimulation in birds can accelerate the development of auditory neural pathways by as much as 5 days. The female cardinal isn't just warming her eggs, she is teaching them to hear before they exist. And here is the payoff. The embryos that received more prenatal song exposure fledged at higher survival rates in the first 90 days of life. She is, from inside a nest, shaping the next generation's neurology. Pull back from the nest, and the picture gets stranger. A 2020 study published in Science by Dr. Davide Dominoni at the University of Glasgow tracked acoustic activity in 22 urban and rural cardinal populations across the eastern United States and measured how their songs had drifted over 40 years of recorded data. The finding was this: urban cardinals now sing at a higher minimum frequency than rural cardinals, a measurable, inherited acoustic shift driven entirely by the need to be heard above low-frequency urban noise. This is evolution happening on a timescale we can watch. But the ripple doesn't stop at the cardinal. Because the cardinal's song is used as an auditory landmark by at least 14 documented species in its range. Other birds orient their own territorial boundaries to cardinal song presence. When cardinals shift pitch, studies have shown that the acoustic ecology of an entire woodland edge shifts with them. Species that share frequency space with cardinals have been documented widening their own bandwidth, making room, in what ecologists now call acoustic niche partitioning. That male cardinal in your yard singing at 5 a.m. is not just staking out his half-acre. He is writing part of the operating system for every bird on your block. This is where the biology becomes almost philosophical. Dr. Stephen Nowicki at Duke University, the same institution where the dawn timing research was conducted, has spent decades investigating what songbird song actually communicates to rivals and mates. His 2002 framework, later extended in a 2018 meta-analysis, established what is called the developmental stress hypothesis. The complexity of a bird's song is not a direct display of current fitness. It is a memory of past hardship. A male cardinal that survived nutritional stress as a nestling, a cold spring, a parasite load, a depleted food territory, will carry the neural scars of that stress in his song-learning circuitry. His songs will be slightly less complex, slightly less symmetrical, and the female can hear it. She's not listening for beauty. She is listening for the absence of defects, running a real-time quality control check against developmental noise from months before she ever met this bird. Every whistle he sends across your yard contains encoded information about events from the previous spring. She hears his past. She makes her future. The dawn song is not a greeting. It is a resume, submitted blind, evaluated by an expert, and judged in the dark. And here is the secondary mystery resolved. The female cardinal's song, the one directed downward into the eggs, has been found to carry the same developmental stress markers as the male's. She's passing forward not just stimulation, but information. The embryo receives, in acoustic form, a compressed history of the world it is about to enter. That is not instinct. That is inheritance through sound. Every organism on this planet is transmitting something into the future through every act it performs, most of it invisible to us. The cardinal figured out how to do it, literally, before sunrise, while no one was watching. What was the first bird song you ever learned to identify? Let me know in the comments. I will see you in the next one.